Okay, you see? Still got the same clothes on. So it's only been a couple of minutes. I just took time to move forward my slides on the computer, which is right here. We're going to now talk about hearing. And when we talk about hearing, we talk about three portions of the ear: the outer, the middle, and the inner ear. Now, the outer ear, you've got this thing here. What do we call it? It's the auricle. Good job. We also have that hole in there. That's called the external acoustic meatus, right? And so the outer ear is going to extend all the way to what? The eardrum. But we don't call it the eardrum. We call it the tympanic membrane. The tympani in the symphony is the kettle drums. Those would be the tympani. And so we have this membrane there that is going to be vibrating kind of like you were beating on it, but it's just air. It's sound. Nuts. It's just sound that is hitting it, and it's going to cause it to vibrate. The inner ear on the the middle ear on the other side of the tympanic membrane, we have a air-filled space in there, and it's the other side of the tympanic membrane, and we got a bunch of little teeny tiny bones that are then going to be vibrating with the tympanic membrane, and they're going to be communicating with the inner ear. Okay, so before we get to that, let's finish our discussion of the outer ear. So the outer ear, we had said we have the auricle. Why do we have that? Have you ever seen in the old movies, nowadays we have hearing aids, right? If you can't hear, you get this thing you stick in your ear, and it's like an amplifier, right? So it makes it louder. But back in the old days, if you watch, it's one of the, Charles Dickens kind of movies or something like that, they have this big, giant funnel that they'd stick in their ear. Why? It's to funnel the sound into the external acoustic meatus. Well, look at this baby right here. It's a funnel. So that's its job, is to collect sound and funnel it into your external acoustic meatus. And it's going to pass down this S-shaped external acoustic meatus, and it's going to hit the tympanic membrane, and the tympanic membrane is going to move with the frequency of sound. Remember, we were talking about frequency before. It's the same. It's sound energy as opposed to light energy, but it has a waveform like we were talking about with vision. And so it's going to vibrate at a certain frequency based on the sound that has come into it. One other thing to talk about, the external acoustic meatus is where we have those ceruminous glands. And we said, what do? They secrete that earwax that you clean out of your ear with a Q-tip, right? Because it can get a little too much, right? Okay, so that is the outer ear. Then we move to the middle ear. And the middle ear is going to, I'm going to show you a picture of this. The middle ear is right here. So you see outer ear here, middle ear is here. And we said, what is it? It is an air-filled space. You get a cold and your ears are popping, right? So what's going on there? I want you to look carefully at this. You see this right here? Hopefully you can see that right there. That is the auditory tube, and that extends down into your throat. And what it does is when you go up and down in elevation, the air pressure on you changes. And so this allows the air pressure inside of that air-filled space to equalize. So it allows the air pressure to equalize. And when you've got a cold and you got all that junk going down into your nose and your throat, it sometimes gets plugged up and you get pressure in your middle ear. All right, so your middle ear consists of the inside of the tympanic membrane, and then we have three little teeny tiny bones, the malleus, the incus, and the stapes. Now, the malleus is attached to the back surface of the tympanic membrane, and connected to it is the second bone, which is called the incus, and connected to the incus is going to be the stapes. Now, the stapes, if you remember, it's that thing that looked like the stirrup on a saddle. It's going to be pushing in a window into the inner ear, something called the oval window. So what happens? We said that tympanic membrane is going to start vibrating, and we've got this group of three bones that are going to be, of course, vibrating. They're connected to it. They're going to be vibrating at the same frequency. And that stapes is going to be punching in and out of a window. Well, on the inside of that window in the vestibule, there's fluid. There's fluid in there, and so the punching in and out is transferring the vibration to the inner ear. Now, if you think about the size of the tympanic membrane from the models in class, and then the size of the stapes, you'd say, well, the stapes is much smaller than the tympanic membrane. And so because of the reduction in size, the sound is in effect amplified, I think we say 18 times. So it's because you have this large surface area that's vibrating, and then this much smaller surface area that's punching in and out of the oval window. Okay, so there are two other structures we need to talk about in this middle ear, and those are these tiny little muscles. Before I talk about it, I want to show you a picture of the malleus, the incus, and the stapes. Now, you might not know it, but that's a dime. You may have forgotten what they look like since we don't really use coins anymore. But that dime, you look at the size of the dime and you look at the size of the bones. There's the malleus, the incus, and the stapes. So you notice there, the stapes has a much smaller surface area than the tympanic membrane. And so we had said that, in effect, is going to amplify the sound 18-fold. Now, in addition, so if we're amplifying that sound 18 times over what it is out here in the environment, that could be really loud. Or maybe you go to a rock concert, or have you ever been to a drag race? Oh my God, you talk about loud. That stuff just thumps right through you. But anyway, how do you keep from damaging your ear? Well, it ends up you have some muscles that can grab onto those ossicles and slow and reduce the amplitude, not the frequency, the energy of the vibration. And so we have the stapedius and the tensor tympani. The tensor tympani and the stapedius are two little muscles that help to control the intensity of the sound that is coming in there. Okay, that brings us to the inner ear. So the inner ear is that thing with the cochlea on it, right? So I'm going to show you a picture again. So here you can see, here you can see how big the tympanic membrane is compared to the stapes. That's where we get that amplification, that 18-fold amplification. The inner ear is this part right here. Now you see this right here, this is where the oval window is, and then there's another window below it that we haven't even mentioned yet that's called the round window. And we'll talk about it here in a minute. All right, so this is all fluid filled, and that center area, if you think about the entrance to a building, people will often say, I'll meet you in the vestibule. And, you know, you say, go down to the library and I'll meet you in the vestibule. And that means you don't have to stand outside. You just go inside the door into that area just inside the door. So that's where it gets its name. Now, the vestibule is continuous with the cochlea. It looks like a seashell, right? And so when we talk about hearing, we're going to talk about the stapes punching in and out on the vestibule, and we have this fluid-filled chamber that is all curled up like a seashell. And guess what? I have a cool slide, the very next one, that is going to show you what the cochlea looks like if you were to unroll it. So check this out. There it is. And I'm just realizing that I probably should stop right here. And we'll come back, and we've been 12 minutes almost now. So I'm going to stop right here because I need to have sort of a continuum of thought to describe how you hear. Okay? Hang on.